Let's look at an example of calculating a diversity index for organisms in a leaf litter sample, such as you're going to be looking at. So you start by just identifying your organisms and keeping a tally. So if I see an ant, and then another ant, and then a pill bug, and then maybe I see something and I've got no clue what it is, so I'd put it down there. And I'd just keep tallying up what I see until I've gone entirely through my leaf litter sample. And you'll probably see more than this, but this is enough to give us an example. The next thing you do is get your total count for each type of organism that's present. And then you add these to find n. So I'd add all of those together, giving me a total of 10 organisms that I counted in this sample. To calculate the diversity of the sample, I use the formula 1 minus d, where d is equal to the sum of little n times n minus 1 over big N, my sample size, times big N minus 1. So how I do that is I take each of these as an individual number for n. I start by going 2 times 2 minus 1. My next one would be 6 times 6 minus 1 plus 1 times 1 minus 1, and then another 1 times 1 minus 1. I'd divide that whole thing by my total sample size 10 times 10 minus 1. If I start by doing my subtractions and multiplications, 2 times 1 would be 2, 6 times 5 would be 30, 1 minus 1 is 0 times 1 would be 0, and the same for the next one. My denominator would be 10 times 9, so I would end up with 32 divided by 90, which on my calculator gives me 0.36. To calculate diversity, 1 minus 0.36 is equal to 0.64. And I'll just write that up here so I can keep track of it. My diversity index for my first sample is 0.64. Okay, let's look at another example. Suppose in my second leaf litter sample, I end up, after doing my tally, with 3 mites and 2 millipedes, 3 beetles, and maybe a springtail. My species richness is the same as in the previous sample. I still have 4 different kinds of organisms. However, the evenness is different, so let's see if this more equal distribution ends up affecting our diversity index. Again, I count them all up, and in this sample I have 9 organisms. I'm going to use my formula again, so it would be 3 times 3 minus 1 plus 2 times 2 minus 1 plus 1 times 1 minus 1 plus 3 times 3 minus 1. If you have 5 different kinds of things, you'd have 5 different numbers to add up here. If you only find 3 kinds of things, you'd only add 3 things. If you're really lucky or really unfortunate, you might find some of all of these, and then you'd have lots and lots of numbers to add up in that numerator of your fraction. This time, our total sample size is 9, so 9 times 9 minus 1 We start to simplify that out. It would be 2. Oops, sorry. It would be 6. 3 times 2 plus 2 times 1 would be 2 plus 0 plus 6 divided by 9 times 8, which would be 14 divided by 72, which equals 0.19. To get diversity, 1 minus 0.19 would equal 0.81. And so my second sample has a higher diversity index, is more diverse than my first sample.